Okay, I'm going to do a quick little discussion on time conversions in particular. We had a question that went out, and it's basically how do we convert time from T solar, right, into, or from the standard time and all the different corrections that come from standard time. How do we convert that into solar time? And so I'm going to write out that basic form. This is daylight savings time. So let's undo that real quick. Okay, so you see here that I've got T solar, and the solar time is equal to the T standard time plus any correction that I have from the equation of time and any correction that I have from the longitudinal correction. And then if we are in daylight savings time, then we're going to need to subtract, we're going to need to subtract 60 minutes, yes. Okay, so I'm going to focus on equation of time and on the longitude correction in the next two steps. So first of all, equation of time. When I go over to looking at the equation of time in the textbook, I sent you a correction for the equations of time. The equation of time has to do with the day n. You input n into an equation for b. That's going to be 360 over 365 times n minus 1, not n minus 81, that's n minus 1. And you're going to get b, and b is just a factor that plunks into these cosine equations in the equation of time. So I've written out right here the full equation of time so that we can save on a little bit of time while we're doing this problem. And you see 229.2 is going to be multiplied first by a constant, then by a cosine factor with b to the first, b times 1, and then 229.2 times a factor where I've got cosine of d 2 times b plus, not negative, plus the sine of 2 times b, right? And so this equation right here, just so we have our idea, that equation is going to pop right into what we would see inside of our equation plot for the analemma. So I can see here that I would have this is going to be January 1st, go all the way through December. I'm going to have plus or minus so many minutes that I can check on this graph. Or if I'm in an exam, I can use this graph to find out based on the day that I have. Okay, so let's go real quick over here. We're going to grab the content from the equation of time. I'm going to copy that and just directly paste it right now so that I can run this through. And what I'm going to see first is that the day is going to be for May 10th. And using my quick calculator, I find out that that day is 130. Going through the full equations of time, I see that E sub t is a value of about 3.8 minutes. And 3.8 minutes, if I check here, if I'm at about 110, so I've got 90, and it looks like I'm going in units of 30 here, so about 110 is going to put me somewhere right up in here at about 3.8 minutes. So we've got the right correction. We've got to subtract out 3.8 minutes, or add in, excuse me, in this case. And then we're going to go over to our next correction, which is going to be the longitudinal correction. So let's first jump over to our correction. So we had T standard. Let's just say that for right now it's 12 noon, right? And we need to add to standard time, we need to add in 3.8 minutes, okay? And then I go to my longitudinal correction, and I'm going to see that my longitudinal correction, I've chosen two locations that are on either side of the Eastern time zone, UTC minus 5. First, I chose Boston, Massachusetts because it's at 71 degrees, and we know that the standard meridian for the Eastern time zone is minus 75, right here and here. Pittsburgh has a longitude of minus 80 degrees, And so we see 71 and 80, and you notice that this is a plus sign because it's actually subtracting a negative angle. So if I run these two guys out, grab these guys real quick, and I run the calculation on these two guys, I'm going to see that I will need to subtract time from Boston, and I'll need to add time to Pittsburgh. And so I would just go over to here in Boston. I'm going to subtract 16 minutes, and so we basically got 4 minutes added minus 16 minutes, and so the solar time is going to be 12 hours minus 12 minutes, which is going to give us 11:48 a.m. So our time corrected solar based on a standard time of noon is going to give us 11:48. And it should make sense, that's going to be in Boston. It should make sense then that if I wanted to go to Pittsburgh, I would be instead having this plus 4 minutes plus, let's go back over and take a look at what our answer was, plus 20 minutes. Right? So Pittsburgh was further west, and so the sun has to travel further before it becomes overhead in Pittsburgh. So I'd have, in Pittsburgh, I'd have 12 hours plus 4 minutes plus 20 minutes, and it would be 12:20 p.m. in Pittsburgh. Okay? And there we have it. So I have two different locations, Boston and Pittsburgh, both of which are showing me my longitude correction. My equation of time I gather using either the equation, or I go right over to the diagram and I would just read off on the diagram where was the right date and how many minutes was on there. I'd add that in. And if I want to run it the other way around, if I want standard time, I'm just going to subtract my equation of time value, and I'm going to subtract my longitudinal correction, and that's going to give me my answer here. Okay? Hope that helps out, folks. Good luck in your studies. Have a good one.